In this video, we will talk about inter-VLAN routing, okay, and the methods of inter-VLAN routing, router on a stick, as well as the layer 3 switching. Let's start with the basics. Guys, a VLAN, as you know, that is a virtual local area network, and one VLAN equals to one broadcast domain, and it provides easy management as well as isolation, if you remember. So if you remember, different VLANs cannot communicate each other without a layer 3 device such as a router or a firewall or layer 3 capable switch. Okay, so by using inter-VLAN routing, you can establish communication between different VLANs with a layer 3 device. As I told you, it might be a router or a layer 3 capable switch. So popular methods of the inter-VLAN routing are router on a stick and the layer 3 switching. Let's start with router on a stick method. Router on a stick is a term frequently used to describe a setup that consists of a router and switch connected using one Ethernet link configured as trunk link. And in this setup, the switch is configured with multiple VLANs and the router performs all routing between the different VLANs. So for this purpose, you create sub-interfaces configured with .1q so they can interact with they can communicate with each other basically. Okay, so here how it really works. Okay, here you could see I have one switch, which is switch 1, and I have this PC, which is PC1, which belongs to VLAN 10. I have this PC, which is PC2, which belongs to VLAN 20, and I have this PC, which belongs to VLAN 30. By default, if there was no router A in this topology, as you know, different VLANs would not be able to communicate with each other. Okay, but by the help of router on a stick, I am basically defining some sub interfaces. Okay, so one sub interface named gig 0/1.10, okay, which is this VLAN ID. Another subinterface gig 0/1.20 for this VLAN, and another gig 0/1.30. Okay, that will help us to have a communication between different switches. So how I am doing the configuration really is on the switch side. What I need to do, I need to create my VLANs and assign those VLANs to that respective ports, right? So basically I have my VLAN 10, 20 and 30. What I'm doing is I'm going to the interface mode for each and every VLAN, and I am typing the switch port mode access for those ports, right? Because there's only one VLAN for each, those are not trunk ports, right? And I'm typing the switch port, access, VLAN, and the VLAN ID. VLAN 10 for fast04, VLAN 20 for 05, and VLAN 30 for 06. On the other hand, there is another interface of this switch which is connected to router A, and that is fast Ethernet 01. And I'm defining this port as a trunk port because it will carry multiple VLANs. VLAN 10, 20 and 30 will be carried by this fast Ethernet 01. That is the switch side configuration. How I am doing the configuration for the router side, by the way, I have my router in here. As I told you, I need to create some sub interfaces. Okay, this Fast Ethernet 01 is physically connected to router A Gigabit Ethernet 01. Okay, this is how they are physically connected in reality. But I am opening 3 different sub interfaces for this Gigabit 01. They are all logical interfaces, not a physical interface. Okay, so the configuration will look like interface gig 01.10.20 and .30. And this time I will go into the config sub if mode, not config if mode, if you pay attention. Then what I am doing, I am assigning IP address for each and every sub interface. Okay, so in here my PC has an IP address of 1041.10.5. And the gateway I am configuring is 1041.10.1. And this gateway, whatever I am configuring gateway as this PC for VLAN 10, I am assigning the same IP address as the sub-interface IP address of the router A's gig01.10. Same applies for 2 and same applies for 3. Okay, those are the gateway IP addresses that I am defining for my PCs. Okay, that is pretty much it. If I want to verify if my router on a stick configuration is working fine or not, I can just try to ping different PCs. Okay, from let's say from PC1 I can try to ping PC2 and see if it's working fine. Also I can try to ping PC3 from 1, or think like you can do a test and see each and every PC is pinging each other or not. You can also run show run command with the router and you can see, as you can do a step-by-step check. You can check the sub-interface configuration, show run interface gig 01.10, 20 and 30, and you can check on the switch side, show interfaces trunk, and you can verify if this interface is performing correctly as a trunk or not. Let's continue with the second method, layer 3 switching. Traditional network switches, guys, operate at layer 2 of the OSI model, while network routers operate at layer 3. A layer 3 switch, that is a specialized hardware device, and that is basically a switch with routing capabilities. Okay, for this purpose we need to configure interfaces called SVIs, which means switch virtual interface, for each VLAN, and put an IP address on it. So this IP address can be used for computers as their default gateway. So how layer 3 switch configuration works? By the way, I just want to highlight one thing. If you have a layer 3 capable switch, you don't need any additional router. Okay, so the switch itself, only one device, will do the routing between different VLANs. Okay, so how I'm achieving this? First of all, within this switch 1, I need to enable the IP routing. The command is IP routing only. And then I am opening the SVI interfaces. For example, interface VLAN 20, and I'm assigning the IP address for VLAN 20, which is the gateway again for this PC 1, and I'm opening this VLAN 30, and that is the gateway IP address that I'm assigning to this SVI interface of PC2's gateway. And I also have this server, which is VLAN 40, and this is the gateway IP address that I am assigning to VLAN 40 SVI interface. So in this topology, since I enabled IP routing with my layer 3 capable switch, and then I assigned the correct IP addressing, PCs will be able to communicate with each other even if they are in the different VLANs. Okay, I'm coming to the end of this section also. Thank you so much for listening to me, guys.